All right, let's look at that problem that for centroid of a composite area. Let's actually just put some numbers to that and solve for the centroid of it. All right. So I'm breaking this up into multiple component areas like we talked about. I'm going to break it up into a rectangle with its centroid being right here, a solid rectangle. I know it had a circle on it. We'll take care of that with the void next. Okay, so x tilde is going to be half the width because it's just a rectangle, so it's 16 over 2, 8 inches, boom. Its y tilde is from the datum up 18 inches divided by 2, 9 inches, boom, we got it, all right? Now, the circle, that one's easy because it was actually dimensioned from the center. The very beginning of the problem showed it dimensioned to the center, which is common for circles if it's like been cut with a drill bit or something. Isn't it usually a dimension to the center? So that's very common. So here we have x tilde for the circle being 10 inches and 12 inches. These are both positive, right? Because we're going to the right of the datum for the x tilde and we're going up for the y tilde. The area of the circle needs to be a negative though. So we'll take care of that when we build our table. So then for the triangle, all right, for the triangle, its centroid is over here. It is, remember, I said 1/3 from the tall end of a triangle. So 6 inches divided by 3, which is 2 inches. So it's going to be 2 inches from the tall side, or you could say it's 2/3 from the pointy end. So it's 2/3 of 6 or 4 from that side over. Obviously, we're going to want to use the tall side, but you need to be fluent in both for triangles. Since the tall side is on the side attached to the rest of our dimensions, it makes sense. So we have 6 inches over 3 is 2, which means that our distance x tilde is going to be 16 inches, which gets me from our datum to the edge of the rectangle, plus the other 2 to get you actually to the centroid of the triangle. That's 18 inches. And then to get you up from the datum, we're actually only going, we're doing the same thing with the triangle. 1/3 the distance from the tall end, which is this end now, or 2/3 from the pointy end. Again, our datum's down here, so we're going to do 18 inches divided by 3, 6 inches. So there's our centroid of the triangle. Now, here's our table. So the areas, I didn't do the math here for you, but I think you should probably know how to do it. You know, base times height, so 16 times 18 is 288. The area of the circle is pi r squared or pi d squared over 4 if you're using the diameter. And it's negative because it's a void. So you can't forget that negative sign right there. And then the triangle is 1/2 base times height. So like 3 inches times 18 inches, 54 square inches. All right. Then our x tildes, we talked about already. We have 8, 10, and 18. 8, 10, and 18. They're all positive because they're all to the right of the datum. And then I just multiply 288 by 8. I get 2,304, and I do the same thing for my others. And then I sum this whole column up, including the effects of that negative sign, and I get 2,639.8. I sum up my areas, and by the way, this is the actual area of our real shape because, it's the summation of all the components that we use to construct it. And we get, again, accounting for negative signs, 278.38. We take the 2639.8 divided by 278.38, and that will give us our x bar. And then our y tilde, we do it the same way. So we had 9, 12, and 6. 9, 12, 6. And then we multiply 288 times 9. We get that number. Minus 63.62 times 12, we get minus 763.4. And we have 54 times 6, 324. We sum that last column, we get 2152.6. Divide that by 278.38, and we get our number. We get our answers. And so we have 9.48 inches and 7.73 inches. Those are the locations of the centroid from your datum. If you did this with your best friend and your best friend picked a different datum, they would have completely different numbers here. But if they picked this spot up here for their datum, it would tell them to go to the left and down. And guess what? It would end up being in the exact same spot that you went to the right and up. It's really cool. Try it with your best friend or any other friend for that matter. So this is what it would look like. Yeah, I don't know if it's exactly drawn to scale, but I did my best. 9.48 inches to the right, 7.73 inches up. There's your centroid. Again, that's where you would stick your finger if this were a flat plate of constant density, and you would balance this horizontally.